Since our last episode, Orzo has certainly been enjoying himself. Unfortunately, Orzo is liking the porch a little too much, and the problem is, up in upstate New York, we sometimes get inclement weather. So, Papa Izzo has decided for the last stage of his project, he would like to create a mouse hole. So we take this board and we drag it all the way straight to the porch, put it on. In that way, we can only open up half the window and the cold air does not come into the house, but little Orzo can go outside on his porch and in his fur coat happily watch the birds. Now, in order to actually draw a diagram for this mouse hole, or Norman window, as it is called in the construction business, we need to draw a circle equation, which, if you remember, is not the same as a linear equation. The linear equation is y equals mx plus b. That would have our slope and our y-intercept. The circle equation is different. Let's drop that down. So for our circle equation, we need a center and a radius. We're no longer looking for slope and y-intercept. We're looking for center and radius because those are the two things that are required for every circle. Every circle must have a center and a radius. So if I am given this equation, I can tell the two most important pieces of information for a circle. Firstly, the center. The center is at 4, 6 because 4 is right next to the x and 6 is right next to the y. And then I can tell the radius. Now, radius squared is 25, so my radius is going to be 5. Draw a beautiful circle using our compass, and we've got a circle on my graph paper. Duplicate that circle with a different center but same radius, just a little bit further up the page, and connect those circles by parallel lines, and now we have a diagram of a pipe or a pillar or any other cylindrical method that we need for construction. Today's mission, unfortunately, is not a cylinder. We need that Norman window. So we start with the circle and we're going to cut the semicircle and put it on top of a nice square or rectangle. Notice the circle on top stays the same as a regular circle. We just cut it halfway through. We duplicate that shape and draw in our parallel lines, and that is how we get that Norman window shape in our diagram, or as Papa Izzo likes to call it, mouse hole. Awesome. But do we remember this whole different equations phenomenon? You see, when we're doing linear equations, we've got slope and y-intercept, and we also have an alternate equation. So our original is slope and y-intercept, y equals mx plus b, and our alternate is point slope form. These are two forms of the exact same line. It's taken depending on what we need. Do we want a point or do we want the y-intercept? What is most important in our diagram and what is most important for the line? Using a bit of math, we can tell that they are exactly the same. So it doesn't matter which equation we use because they're the same equation, they're just reorganized versions of each other. Well, guess what? Same thing happens with circles. Circles sometimes have alternate equations as well. We've got our center and we've got our radius for our circle equation. That would be the center-radius equation of a circle. However, we also have what we call a standard form of a circle equation. This would be the standard form. Notice how we've got x squareds, y squareds, regular x's and y's, and then a constant with nothing attached to it at all. Well, just like before, using a little bit of math, we can take the standard form and go back to the center radius form. But it is a very complicated process. It's a whole 6 steps, so buckle down, it's going to be rough. First step, we need to divide by the number in front of x squared. So we divide everything by the number in front of x squared. In this case, it's 10. Everything gets divided by 10, and we now have a much more simplified version of our standard form. Step 2, get the lonely number to the other side. That constant needs to go to the other side. So in this case, the plus 27 is subtracted. Once we get it to the other side, step 3. Step 3 is to organize the x's and the y's. Notice all of the x's should be together, all of the y's should be together. It's a very big segregation issue here. But anyway, we've got x's, we've got y's, and then we've got the lonely number on the other side. Step 4. Step 4 is we need to add a box and a triangle. Now we add a box to the x's, we add a triangle to the y's. Notice whatever you do to one side of the equation, you have to do to the other side. So we've got to add a box and a triangle to our little constant over there. That would be step 4. Step 5, we are going to write exactly what we want to have happen. We want it to look like the center radius form. So the parentheses with the x in the squared, parentheses with the y in the squared, equals, hopefully, our radius squared will be on the other side. And then we get to our 6th step, which is the most complicated step of the process, and also my favorite step. What we do is we take the b term and we half it, square it, add it. What does that mean? Well, if we look at the x's, there's only one number involved in the x's. That's what we call our b term. And we take that -8, half it, square it, and then add it over to the other side. Now we do the same thing with the y's. So the y's only have one number left. That should be the -12. So we half it, square it, and add it to the other side. Totaling up my answer to the other side gets me a nice 25. And if you look, this is exactly the same equation we used for our Norman window, with the 4, 6 as our center and the 5 as our radius. So we've got our center and we've got our radius, and we have proven that this standard form of the equation is actually the same equation as our center radius form of the equation. It's just far more complicated. So complicated, in fact, that it's got 6 whole steps to get there. Because it's such a complicated process, I want to do it once more before we go on with DIY with Papa Izzo. So, larger steps, we're going to work from this recipe and take this very ugly standard equation and boil it down into a very nice center radius form of the equation, one that we could graph and one that we could turn into either a pipe or a Norman window or whatever else we might need for our project. Step 1, divide by the number in front of x squared. In this case, it's 7. So we take our standard form and divide everything by 7. And once we have divided everything by 7, notice 70 goes down to 10, 105 goes down into 15, 0 divided by 7, still 0. Fun story. Step 2, get lonely number to the other side. So we add 15 to both sides. Okay, so now we've got our x's and y's on one side, lonely number on the other side. Got to get that constant to the other side. Step 3, x's and y's together. Segregate the equation fully. So we've got x's, we've got y's, we've got our constant. Now add the square and the triangle to both sides. got to add square to x, triangle to y. Do not forget to add both the square and the triangle to the other side. Because if we're adjusting the x's and we're adjusting the y's, the constant needs to make up for all of that. Set up the center and radius form. This is what I want the equation to look like. And step 6, half it, square it, add it. So we take our x's, we've got -10, half of that is -5. Squared, -5 times -5 is +25. And add it to the other side. Now, notice, in this case, we've got a +6 for our y's. So when we half it, square it, add it, we're taking that +6, which means my y is going to be a +3. Halved it, squared it, +3 times +3 is 9, and then add it to the other side. Get all of our constants together, and we get a 49. Alright, now here's the issue. Next to x is a 5, but next to y is a +3. So certainly the whole center and the signs are screwed up. How do we deal with this? It's easy. We're going to flip the signs. So my center is going to be 5, -3. Notice, for the center, we always flip the sign. So it's right next to x, right next to y, you just flip the signs. And then of course our radius, it's going to be 7 for this circle. Now back to the exciting part. So here we have the board that Mama Izzo painted. Papa Izzo is going to sketch out the mouse hole so that we can carve it out with the power saw. After measuring orzo again, Papa Izzo wants to shrink the mouse hole. A nice, simple dilation. After using the circular saw, he goes for the jigsaw to cut out the more finicky aspects of our mouse hole. More sanding! Yay! And now it's time to show Orzo our improvement. Here he is, hanging out on his porch, watching the birds in the garden frolic.